Hi, I'm Darren and welcome to Level Up Double E Lab. One of the most important things I have to take care of on my DX-60 project is the original wire harness. Now, it's in terrible shape, I can't use it, and I can't buy a new one, I can't buy a new old stock one, so I'm gonna have to make one from scratch. Let's see how that turned out. Let's talk about the wiring on the DX-60. Now there's one main wire harness, this guy right here, and a bunch of point-to-point wires, some on the bottom, the side of the chassis, some on the top of the chassis to make the final connections. This main harness is in pretty poor condition. It's missing a significant portion of the lacing in this region all the way up to here, and I think the reason is at some point the heater filament wire that's in this section had melted because I found a chunk of brown insulation that was kind of stuck in there, and there's also this extra yellow wire that somebody put in here, and I think that was to fix the problem. Now I added these wire ties just to keep it from falling completely apart, so this whole area is just in terrible shape. Also, the insulation itself is starting to get a little dried out. I mean, it is decades old. It's going to happen to old wiring. And then the last consideration here about the wiring is I'm planning on making some modifications, not the least of which is putting in a push-to-talk module and then reconfiguring the power supply area. So all things considered, it makes a lot of sense for me to make a new harness for this project. I don't think it'll be that difficult to make a new wire harness for this DX-60. First of all, it is a fairly simple harness. There aren't that many wires in it, and there aren't that many connection points, and there aren't any inline splices anywhere. Plus, I can reverse engineer this very easily. I got a sample here and I can carefully trace it back from one point to the other, which I did to make a wiring diagram, which I'll talk about in a minute. And then lastly, the Heathkit manual has a lot of detail about it that's very helpful, and including things like what size, what width it's supposed to be this way, and the height and so on. So all those factors are going to make it a lot easier to come up with my own. So like I said, I made a wiring diagram of the existing harness before I start thinking about the modifications I need to make to it. So let me show that on screen right now so we can see what it looks like. Now there's lots of ways to make a wiring diagram, and the method that I decided on here is pretty simple. I'm just showing a illustration of all the breakout points, starting with breakout point A, and then B and C, and going counterclockwise around the harness. And then at each point, I've got these little rectangular notations that show what wires there. Obviously, the color indicates the color of the insulation. And then there's three sets of information there. There's a wire number, which is just starting at 1 and counting all the way up for all the individual wires that are in there. And then in the middle, that's the control or the tube or the terminal strip that connection goes to. So for example, AA is the microphone jack and AB is the function switch, and those come directly from the Heathkit assembly manual. And then the last set of information there is the position on that particular object. So 5-AH-1 would mean that's wire number 5. It goes to AH, which is the meter switch, and it goes to position 1 on that meter switch. And so just following that format, I built the existing wire harness diagram this way. And then of course I made a modified version to show the changes that I need to make. I need to add a separate little breakout area here for the connections that are going to go to the push-to-talk module. I made some changes to the power supply routing, just a few changes there. So this will be the diagram that I'll be following to build my new harness. For the actual assembly process of the wire harness, I need something to hold the work in progress together. You can't just build a wire harness in free air. It's not practical to do that. So one of the more common approaches is to use something like this, a nail board. Now, first of all, my apologies to anybody who's watching who actually works in the wire harness industry. There are far more sophisticated pieces of hardware that I know you guys use when you lay out a nail board for production use. I mean, this is about as simple and as primitive as you can get, but I think it's going to work fine. Let me take the harness and show you how it fits in here. So, each of these pairs of nails along here lines up with a particular breakout point, and then other nails are there just to guide the overall shape of the harness. And so I built this off of two sources of information. Obviously, the existing harness, plus there are dimensions that are in the Heathkit manual. This is 9.5 inches high from there to there and 13 inches wide from here to here and so on. So I think this is going to be a great aid for me when I'm laying out each individual wire and getting it positioned. If I need additional support to keep the wires down and kind of bundled together temporarily, well, I'm just going to use some of these standard wiring clips that you can get at any hardware store, and some of them I think I can just bend out of the way to put wires in, but we'll see. Again, this is my first time doing this. I'm not professing to be an expert in this by any means, but I think this technique is sound, and for a simple harness like this, I think it's going to work fine. And the last consideration I want to talk about with it right now is after I get all the wires put in there and cut the length, and of course I'm going to cut them longer than the existing wires, an inch or so longer, so I get extra length to work with. But after I get them all in there, how am I going to bundle it up? The existing harness is an excellent example of lacing, and even over here on the side, you can see this is very precise, the spacing between all these lacings. And then there are tricky knots that you do whenever you have a breakout and knots at the end. I would dearly have loved to try to practice that technique on this harness, but I just simply don't have time. I run into so many other issues on this project that I'm not going to spend hours and hours practicing my technique. I do have the actual material. I've worked on a very simple harness in the past, and it took me a little while to get at least the basics down, and it looked like it would be kind of fun and rewarding, but again, I got to be practical here. So instead of lacing it, I'm just going to use some spiral loom like this here. This is 3/16. I'm going to need to get some 1/4 inch because I think this is going to be a little too small for the thicker areas of the harness. So just going to take the easy road for putting some loom on there. And then lastly, of course, that's got the advantage of if I do make a mistake and I need to take a wire out and redo it, or if I forget one entirely, it's easy enough to undo that, get the wire that I need in there and put it back on. So that's going to be how I'm going to tackle the wire harness on this DX-60. Here's my DX-60 harness with all the wires cut and in place. There are 26 individual wires in it, including the new circuits that I added, and using my wiring diagram as I went along was very handy. I could just check off one by one as I put these in place, and then of course I used the old one as a gauge to make sure I made the lengths about an inch or so longer than the original to give myself some slack to work with. Most of this wire is 22 gauge wire, just plain old PVC insulation, but there's a couple of unique wires. This one here is 18 gauge, and that runs from breakout point E to breakout point K up here, and that is for the filament heater in the 6146 final tube. That's higher gauge, or lower gauge rather, larger diameter, just to reduce voltage drop, I guess, from here over to there. And then in the original, there was also an 18 gauge wire that went from breakout point F on the high voltage, the 600 volt off the high voltage power supply into the harness and up to here for the plate on the final tube. And what I decided to do there, I've got some Teflon insulated wire. It's good for that high voltage, and I just put that in place. Now it's not 18 gauge, it's just 22 I think also, but there's not enough current going through there to need the higher gauge, but certainly having the better insulation is a good idea. My construction technique worked very well. I was happy with how this all turned out. It only took me between 2 to 3 hours to do the work that you see right here. And I was being careful going through each wire to make sure I had them right. And using these staples that have just a single nail in them worked out very well, because you can see up here I've got one that shows that I didn't drive the nail in all the way, and that lets me spin it out of the way if I need a little more room to get it in place, or I can put it back to where it originally was to help clamp the wire down and keep it in place. So that worked out quite well. I'm ready to wrap this harness, and I've changed my mind. After spending a few hours laying out all these wires and reflecting on what I was going to do with this split tubing, I realized several things. One is it's really not going to save me much time putting this stuff on, because you don't just slide the wires in. You have to open it up and wrap it around and pinch the wire bundled together and make it nice and neat as you go along, so it's not all lumpy. I'm going to be kind of doing that with lacing anyway, so I'm not going to save that much time. A second realization is I was just fooling myself about ease of rework. By the time I put this in the chassis, start making some soldered connections, and then find out, let's say, worst case, I missed an entire wire, I'm not going to pull it back out and put that extra wire in there. And I'm certainly not going to be able to open up that tubing inside the rig. There just isn't much clearance in some of these areas, especially up here at the front panel where the function switch and the drive controls are. There's just not that much space. So that really isn't a factor. The other factor with this tubing is it adds a not insignificant amount of thickness. And again, back to these tight areas, the existing harness barely fit in there. So if I add the thickness of this tubing, well, I think I might be in trouble. And the lacing barely adds any thickness at all. So all those things considered, I decided that I need to change my mind. And I'm feeling better about my attempt now because I went online, did some more reading, some more study, and I found a pretty decent reference from an old U.S. Navy workmanship standard that gave a few tips about how to start and finish a particular run of lacing. So fingers crossed, I think it's going to go easier than I feared. And the last thing I'll say here before I get started, I'm not going to start lacing at one end, say this end here, and work my way all the way around to the other because as good as this board is for me, there still is a fair amount of slop in these wires. There's a few twists and waviness, and as I'm bundling this with the cord, it's going to get nice and tight and neat. And if I start at one end, I'm afraid that all those errors are just going to get pushed down, and by the time I get over to this end of the harness, I'm going to be way off with everything shifted. So I'm going to split the difference. I'm going to start here in the middle and lace it around this way, and then start a new knot, say here, and lace it that way. And I think that'll just help reduce that amount of error from pushing all the waviness out. So, okay, at this point, it's time. I'm going to start it, and we'll see how it goes. Okay, I finished the lacing, and this is the end product. I'm very happy with how this turned out, and it was a fairly enjoyable experience. It took me about an hour, just over an hour to do this, and I was listening to the radio, listening to my beloved Cubbies, and they were actually winning when I had it on. So all in all, it was kind of therapeutic to do this, especially once I got into a groove of getting the starting knot done and just repeating that lock stitch and that lock stitch and that lock stitch and just working my way down. I'm glad I had that guide because there's actually two different ways you can do these lock stitches, and only one of them is correct. One is going to cinch tight as you go along, and the other one is not. So I was careful to make sure I did it the correct way. The other thing the guide recommended was for the length of harness that you're going to lace, you would play out about 2.5 times that length in your lacing cord. I went a little longer, about 3 times, and I think you might be able to squeeze it with 2.5 depending on how tight you make your spacing between your lock stitches, but 3 times worked out fine. As you can see, I had to pull out some of these nails and some of these clips, some of these staples. I just needed the room as I was working along. So all in all, I am really happy with how this turned out. If I was critiquing this, a professional would most certainly keep more even spacing between the lock stitches than I did, and probably put a few more in certain areas, but I'd say not bad. I would grade myself for my first effort on doing a harness of this size. So now it's time to get this off the board and get it back into the DX-60. Having this harness done is pretty much the last critical item that I needed to line up in order to put this DX-60 back together. In addition to it, I've got solutions for that bad loading coil. I was able to find a replacement online along with a few other parts that were in bad shape on my rig. Unfortunately, these did come from a salvage unit, which is basically the last resort on these old radios because you can certainly use those parts to get yours working again, but the net result is there's one less of those units now in the world that had to be sacrificed in order to get another one up and running. But sometimes that's what's necessary. On a little more positive side, I was able to find a source for carbon comp resistors, carbon composition resistors. These are important to use in old RF gear because if you're using some of the modern ones that have a lot of self-inductance, you can run into trouble with RF circuits. So it's nice to be able to use carbon composition resistors. I did find some replacement tube sockets, as I'll show in an upcoming video. I got a problem with one of them, so I had to find replacement tube sockets. And then lastly, I did end up painting the chassis, and it turned out really nice. So this is ultimately going to be like a new Heathkit assembly, and I'm very excited to be at this phase, and I think it's going to be a lot of fun to put this guy back together and get it on the air again. I thank you for watching this series. I do hope you're enjoying this material, and as always, enjoying my channel. So until next time, bye for now.